Alright, I'm unable to be with you today, so I thought I'd do a video of some notes. And we're going to look at section 2.7, where we're proving angle-pair relationships. We'll do some proofs and we'll talk about angle pairs. You'll see we've got some theorems here, and actually at the bottom, postulate as well. But you may remember, I don't care about the theorem number. I care more about what the theorem says, and we'll go ahead and refer to it by its name when we're doing proofs. So we've got a right angles congruence theorem. Here we've got a congruent supplement theorem. Here we've got a congruent complements theorem. Let's start with those. The right angles congruence theorem tells us that all right angles are congruent. That seems kind of obvious, and it's an easy theorem to prove, but we can use that as a shortcut at times. For example, example 1. First thing we have is segment AB is perpendicular. That upside down capital T is the perpendicular symbol. So these two lines are perpendicular. Those two lines are perpendicular. That was given. Now apply the definition of perpendicular lines. I've got our definitions here. Perpendicular lines definition, if two lines are perpendicular, then they intersect to form a right angle. So let's apply that. Since AB is perpendicular to BC, they intersect at angle B. We know that angle B is a right angle. In addition, DC and BC, BC intersect at C, so angle C is also a right angle. So I'll say angle B and angle C are right angles. That's what I can conclude from that definition. Now, I'm trying to say that angle B is congruent to angle C. We can use our theorem. All right angles are congruent. And here we said B and C are right angles. So now I can state that they're congruent. Angle B is congruent to angle C. And the reason for that is the right angles congruence theorem. And I can do some abbreviations here. Right angles congruence theorem. It actually saves me several steps because I have that theorem. I don't have to say that they're both 90 degrees and do substitution and stuff like that. So it's just kind of a nice quick jump to that. Next theorem, congruent supplements theorem. It's saying, it's a little bit like transitive but talking about supplements. If 1 and 2 are supplementary and 3 and 2 are supplementary, then I can conclude that 1 and 3 have to be congruent to each other. And the congruent complements theorem says if 4 and 5 are complements and 5 and 6 are complements, then 4 and 6 have to be congruent to each other. So let's see that in this example number 2. We have to prove that two angles supplementary to the same angle are congruent. So we're trying to prove this theorem. So angle 1, angle 2 are supplements, 3 and 2 are supplements. Those are our givens in the first line there. Definition of supplementary angles. Well, if two angles are supplementary, then their measures add to 180 degrees. So, measure of angle 1 plus the measure of angle 2 equals 180 degrees. And measure of angle 3 plus the measure of angle 2 equals 180 degrees. Transitive property. Well, both of these things, you may notice they both equal 180. So the measure of angle 1 plus measure of angle 2 and the measure of angle 3 plus measure of angle 2 actually equal each other. Since they both equal the same thing, they equal each other. That's the transitive property. So measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 2. Now, it looked like they kept the 1, kept the 3, but they got rid of the 2's. Well, you can do that by subtracting. So we use the subtraction property of equality, or POE. Lastly, they tell us they want us to prove that the angles are congruent. We just said they're equal. Well, that means that they're congruent using the definition of congruent angles. Sorry, I'm looking for that on my sheet here. It's the very first one. And here I'm going to work backwards. If two angles have equal measure, and I had two angles with equal measure, then I can conclude they are congruent. So angle 1 is congruent to angle 3. The definition of congruent angles is the reason. Okay, now we have what's called linear pair postulate. We actually used it already in the last section, but we were a little premature on that, but here it actually is. If two angles form a linear pair, then they're supplementary. And we already knew that from the first chapter. We kind of talked about it. It's why it wasn't a bad thing to jump the gun there. But we actually have a name for it now, linear pair postulate. And you see that that's on our sheet as well, linear pair postulate. And then we also have this vertical angles congruence theorem. We talked about this as well. We identified in chapter 1, we figured out it was true, that all vertical angles are congruent to each other. So remember when we have kind of an x-shaped, vertical angles are opposite each other, so 1 and 3 are vertical angles, well, they're congruent to each other. 2 and 4 are opposite each other, so they're vertical angles, they're congruent to each other as well. It's not that all 4 equal each other, but they go in pairs. All right, that is it for notes. So your assignment is to do the problems on the back side of this sheet. And those will be due on the block day.